very happy to introduce Stephen Yang with NeuroSolid today, a super exciting company doing physics-enhanced AI for accelerating material modeling. And coming out of Nikolas Bouklas' lab, who's an associate professor of computational mechanics and multiphysics. And Stephen has been an Ignite Fellow for the Venture Group. So Stephen, just take it away.
Yeah, thanks for the introduction. Our startup is NeuroSolid, and we are building physics-enhanced AI for accelerating materials modeling. I am Dr. Stephen Yang. I'm the CEO and co-founder. I co-founded it with Dr. Nikolas Bouklas. As mentioned, I graduated from the Ignite postdoc fellowship for new ventures at Cornell University. And my co-founder is associate professor in mechanical engineering and also the director of CAD and machine learning research at AI startup Pasteur Labs. So we have advisors from that are leaders in scientific machine learning and AI, as well as engineering simulations in the defense industry and academia. So the problem today is that over 600,000 engineers use FEA engineering simulations, but only 1 in 20 have the expertise to generate material models. So what I'm talking about, like material models, are how do we virtually represent how materials behave on a computer, right? So how do we translate experimental measurements into a model that can be run on a computer in a simulation? So there's been an explosion of new materials, right? So engineering materials now exceed over 300,000. But manually figuring out mathematical models for each and every material is intractable, and even experts can't keep up with this huge explosion of materials. So our physics-enhanced AI ML technology turns this bottleneck into a scalable opportunity. So when we're thinking about engineering simulations, right, there are generally three things that you need to input to get a result. So we have our material model, which is the focus of our work, the geometry of the part that you're trying to simulate, and then the loads and boundary conditions, basically representing what the part's going to experience in real world conditions. You put that into your solver, and then you get the predictions of how that component or design is going to perform. But then the key thing is that we've noticed that currently most AI for science is focused on solution acceleration, right? So replacing the engineering solver that we have currently, and also doing generative geometry design. But as you see here, one of the key inputs is actually describing how materials behave, right? And without that information, you won't be able to get trustworthy and accurate results. So our solution is using AI ML automation for material modeling. Here we have materials data, right? So this could be things collected by chemists or materials engineers from experiments, or also from simulations of the material, right? It could be molecular dynamic simulations, it could be engineering simulations of a composite structure. And our technology can learn from this multimodal experimental data using physics-enhanced AI to be able to generate material models that can actually integrate with standard software. So part of our key technology is that we have these neural networks that have physics constraints, and we can sparsify the network and do other techniques and able to make it compatible with current engineering workflows. We've demonstrated our technology on several materials, classes, and settings, right? So this includes polymers and polymer composites, metals, multi-material additive manufacturing, which is a very upcoming manufacturing technology, and also biomaterials. As you see, like this, the thing we're building is actually broadly applicable across a wide range of industries. So the way we fit into other engineering software and the current landscape, right, is that most material informatics softwares are actually focused on materials databases, essentially replacements for the paper, right, that you get when you buy a material that comes in the box, right? So you can look it up on a database and compare different materials. What they're not doing today is having a pipeline that connects this material data into a model that you can run on a simulation. Um, so this is, I think, where we really fit into this, that not only are we using AI for property prediction, like predicting a specific value of a specific test, right? We have a pipeline that translates this data into simulation-ready models. And the market for this is actually quite big, right? So the global market for um, finite element or engineering simulations is more than 200,000 licenses, right? So if we are conservative and we think that we can sell, just say a $5,000 license for every single one, it's going to be over $1 billion market. Obviously, that's not fully realistic. So our addressable market in the US, right, if we are thinking about for high fidelity simulations, right, our annual recurring revenue with a good market penetration can be over 100 million per year. But right now we are targeting a wedge for the U.S. materials and manufacturing industry for polymer components, rubbers, and gaskets and seals, tires, right? And with like 20 site-wide licenses, this could be a very attractive $15 million wedge that we can address very quickly. So some updates. Currently, we're in the diligence process for a $1.5 million SBI or fast track, and that will provide a 3-year execution runway in order to de-risk this AI modeling technology for additive manufactured materials. And we've had good support from major prime defense contractors and also materials companies, including Stratasys, Aerospace, Boeing, and 3M. So the ask that we're presenting today is that we are in the process of trying to raise a $3 million seed round, which will provide a 24-month runway. And we're going to use this money to make our software production ready for engineering workflow, establish paid pilots, and be able to make some key hires, including machine learning engineers, simulation specialists, and product managers. Thank you, and I would like to take any questions.
Thank you, Stephen. That was very interesting. Do we have any questions out there? Here we go. Richard.
Yes. Hi, Stephen. This is Richard Curtin from Silicon Catalyst. So we're an incubator for early stage companies in the semiconductor industry. We worked with Robert and the team there at Praxis for a couple of years now. Very intriguing opportunity here to take the technology and apply it to the materials research that's going on in the semiconductor industry. And specific to that, as part of Silicon Catalyst, we have 3 strategic partners that are in the materials space for the semiconductor industry. So we have DuPont, which is now called Qnity. We have Dexerials out of Singapore. I'm sorry, out of Malaysia. And we also have EMD Electronics, which is part of Merck. And so the question I would have is, have you pursued anything? And I know you have that on the competitive landscape with Ansys, now Synopsys. Have you made any progress with some of the materials-based companies for the semiconductor industry?
So we had some customer discovery interviews with AMD, right? And I think right now, the way our technology could fit best with what they're doing is modeling like the deformations that can occur, thermal deformations that occur between the packaging material and the wafers, right? So there's a lot of like work being done about modeling like the polymer encapsulation or just like mismatching materials, right? So when you heat it up, right, you can end up with a lot of strain within, right? So that's definitely one avenue that we are exploring, and something that's really important. What they've told us is that they do have quite a lot of challenges modeling right, encapsulation materials and packaging materials for these types of applications. So it's definitely something that we're exploring.
This could be an interesting thread for funding for pilot projects as well. I mean, if you look at, so AMD is a consumer as more than a producer. And I'm coming back to the root technology organizations like a DuPont, Qnity, that would be, and potentially even some of the packaging organizations, the OSATs, that might be interested in this. So intriguing. I'd love to follow up with you and
Yeah.
maybe explore how we can collaborate with you and speak to Robert Sharp there and chat with him about what we've been doing with some of the Praxis companies. So
Yeah, awesome. Yeah, like I'm meeting with Robert next week, so we can try to get connected. Awesome.
okay, good luck. Yep, looking forward to seeing what we can do.